In our lesson today, we're going to have an application of percentages, which is called percent change. A percent of change describes how much a quantity has changed expressed as a percent of the original quantity. It's always important to remember that when you're talking about a percent change, it's expressed as a percent of the original quantity. We'll talk more about that in a little bit. When the quantity increases, the percent change is called a percent increase. And when the quantity decreases, the percent change is called a percent decrease. And so in our first example, we have a frog. And then we're told that a pet frog measures 51 millimeters in body length while it's sitting, which we can see right here in the picture. Its body length extends to 89 millimeters while jumping. And we see the frog jumping, and it extends to a length of 89 millimeters. It says find the percent increase in the body length of the frog from sitting to jumping. Round your answer to the nearest percent. Okay, and you'll notice right here in this box, I'll go ahead and put a little star next to that, that our equation that we're going to use for percent change is change equals the rate times the original amount. Remember that the rate is going to be written in decimal form. Okay, and this is very similar to the percent equation that we've been working on. Instead of saying part, they've got change there. And instead of saying whole, they've got the original value. And again, because the amount of change is expressed as a percent of the original quantity, percent of the original is going to take the spot of the whole value. So it's the same idea as part equals rate times whole, only now we're calling it change equals rate times the original amount. And so in this example, again, we're trying to find the percent increase in the body length from sitting to jumping. And so here in step one, the first thing we have to do, we have to calculate the amount of change. Calculate the amount of change. And the way that we're going to do that is look at the lengths of the body of our frog. It was 51 millimeters while it was sitting. It's extended to 89 millimeters while jumping. So to find how much it's changed, we're going to subtract those amounts. 89 minus 51 is equal to 38. It was a 38 millimeter increase in the frog's body length, a 38 millimeter increase. That's the value that we're going to use for the change in our equation. So let's go ahead and write the equation down. The change is equal to the rate times the original amount. And we've just calculated the amount of change to be 38 millimeters. That's going to be equal to R, the rate, that's what we're looking for, times the original amount. Well, the original is the one that happened first. The frog was sitting first, so the original amount was 51 millimeters. We're trying to figure out the value of R, so we're going to go ahead and divide each side by 51 to get R all by itself. That's on the right-hand side. And if we go ahead and enter this into our calculator, 38 divided by 51, we get a long decimal that we're going to write out the entire decimal, 0.745098039. That's the value of the rate as a decimal, but we know that our rate has to be in a percent form. So we're going to go ahead and convert this into a percentage, moving the decimal point to the right 2 times. And we get 74 and 509.8039%. Okay? So we calculated the amount of change first, 38 millimeter increase. Then after we were finished with that, we set up the percent change equation. Set up the percent change equation in step 2. And then once we've got it set up, we had 38 equals R times 51. After that, we calculate the percent change. In this case, we had to divide each side by 51 to get R all by itself, which gave us this long percent here. Okay, now don't forget back at the top here, we were told round your answer to the nearest percent. So I'm looking at this number right here. It looks like 74%, but I checked the tenths place and I see a 5, which is going to be enough to round us up. So this is going to be approximately 75%. And so now we can go ahead and answer the question by writing a sentence. we can say the frog's body length increased. Remember, it was 51 millimeters, then it went up to 89 millimeters, so it increased by about 75% from sitting to jumping. Okay, the frog's body length increased by about 75% from sitting to jumping. In the next example, we're told that Patty got a score of 80 on the first math test. On the second math test, she received a score of 96. We want to know what's the percent increase from test 1 to test 2. So again, we're going to use the equation change equals rate times the original. And again, we have to calculate how much change there was. Well, Patty had an 80 on the first test, a 96 on the second test. So we'll do 96 minus 80, and we'll see that there was a 16-point increase for Patty from test 1 to test 2. So that's going to be the amount of change. 16 points equals, we're trying to figure out what the rate of change is, the percent increase, so we'll call that R, times the original amount. Well, again, the original test score was her first test, which she scored an 80. And now that we've got the equation set up, let's go ahead and solve for R by dividing each side by 80. On the right, 80 divided by itself is 1, leaving us with R. And then on the left, 16 divided by 80 is going to give us 2/10. So 2/10 is the value of R, but again, we need this to be a percent. And so we know that 2/10 is the same as 20%. And so we can say here Patty's test score increased. Patty's test score increased 20% from test number 1. In example 3, we're told that Tim got a score of 96 on his first math test. He didn't bother to study, and he received an 80 on the next math test. What is the percent decrease from test 1 to test 2? And so again, we'll go ahead and write our equation out. Change is equal to the rate times the original amount. And once again, we have to calculate how much change there was. Tim had a 96 and then got an 80. 96 minus 80. This is a 16-point decrease. Tim had a 16-point decrease from test 1 to test 2. So the amount of change is 16 points. We're looking for the rate. In this case, it's a percent decrease, so we'll call that R, times the original test score for Tim. On his first test, he had a 96. So 16 equals R times 96. Now to solve for R, let's divide both sides by 96. On the right, 96 divided by itself is 1, leaving us with R. On the left, 16 divided by 96 is 16/100ths with the 6 repeating. Only put your bar over the 6. We need to convert this into a percentage. So again, move that decimal place 2 places to the right. And we're going to get 16 6/10 repeated percent, which is the same as saying 16 2/3%. And so we can say Tim's test score decreased. It decreased 16 2/3% from test number 1. Okay. So we saw Patty's test score increased 20% from test 1, and Tim's test score decreased 16 2/3% from test number 1. Now, in these two examples, Patty and Tim, their test scores were the same values. They each had an 80 and they both had a 96, which means that their amount of change was the same. They each had a 16-point change. Patty's was a 16-point increase. Tim's was a 16-point decrease. Since their test scores were the same and their amount of scores were the same, why were the percent changes different? For Patty, it was a 20% change. For Tim, it was a 16 2/3% change. Okay, and so we can say that the percent changes are different. The percent changes are different Because, well, let's take a look at why. If I look at the two equations that we set up here, for Patty, again, change was 16. For Tim, change was 16. We were looking for the rate in each example, but notice here, Patty's original score was an 80 and Tim's original score was a 96. The change is always based off of the original score. This led to different percent changes. So the percent changes are different because the original scores were different. Okay? One might be tricked into thinking that because they had the same test scores and the same amount of change that the percent changes would be the same, but they're not because the original scores were different. In the next few problems, our percent changes are going to take place in the retail world, meaning shopping or selling things. And the retail world calls a percent increase a markup. A store is going to mark up a price of an item before they sell it to you so that they can make a profit. The retail world calls a percent decrease a discount. So if they're looking to get rid of extra items, they might put it on sale. Let's call that a discount. In example 5, we're told that a ski jacket was originally priced $95. It's discounted $28.50. What is the rate of discount? So let's go ahead and set up our equation. Change equals rate times the original amount. Okay. And we can see here that the original price was $95. And we want to know what the rate of discount is. So we'll call the percent R. And pay attention to the wording here. It says it was discounted $28.50. That's how much the price is changing. So we don't have to calculate the change in this example. It was given to us. $28.50 equals R times 95. And so we're going to get the value of R by dividing each side by 95. 95 divided by 95 on the right is 1, leaving us with R. 28.50 divided by 95 is equal to 3/10, which we know is the same as 30%. 30%. So we can say that there is a 30% discount. In example 6, we have another ski jacket. This time a $45 ski jacket is on sale for $36. What is the rate of discount? Okay, so for my rate, I'm going to put R because that's what I'm looking for. The original price of the ski jacket here was $45, so R times 45. And the change, well, we weren't given the change like we were over in example number 5. We know the old price was 45 and the new price was 36. So to calculate the change, do 45 minus 36, and that's going to be 9. There's a $9 change in price. 9 equals R times 45. Let's divide each side by 45 to get the value of R. 45 divided by itself is 1, leaving us with R on the right. 9 divided by 45 is equal to 2/10, which we know is the same as 20%. And so for this ski jacket, there is a 20% discount. In our last example, a silver chain has been marked up from $20.50 to $31.57. We want to know what was the percent of markup. And so we're going to use our equation one more time. Change equals the rate times the original amount. I'm trying to calculate the percent of markup, so my rate is going to be R times the original price that the store paid for the chain was the $20.50. So R times, I'll put this in parentheses actually, $20.50. And I need to know how much change there was in order to calculate the percent of change. So we'll go ahead and do the subtraction in their prices. $31.57 minus $20.50 is equal to $11.07. There was an $11.07 markup. This is going to be your amount of change, $11.07. To figure out the value of R now, let's divide each side by $20.50. And that's going to give us a value of 54 hundredths for R, which we know is the same as 54%. So there was a 54% markup in the price of the chain.